when we talk about mutually exclusive, mutually, what does it mean if something is mutual? Yeah, you agree. If there's a mutual breakup, that means together you decided to break up, which we all know mutual breakups never happen. Somebody's always lying because they, right? Just kidding. It does happen. All right, so mutual means like together you agree, but what does exclusive mean? If you're invited to an exclusive event, does that mean everyone gets a invite? Yeah, you get picked. It's kind of separate. It's on its own. So it's kind of goofy, this word mutually exclusive, because mutually means like together, but exclusive means you're getting picked or it's special. You're on your own. Okay? So when you look at that word mutually exclusive, okay, do you know where to find any of the notes? Okay, so when are we going to do that? School is going to show it to you at some point, and you need to do it. So when do you want to do it? Okay, I'm going to go back to okay. All right, so mutually exclusive, mutual means together, exclusive means like on its own, it's separate. So mutually exclusive means that we have two or more events, or characteristics is what we should say. Two or more characteristics that cannot happen at the same time. There's a question on your test where it's going to go through situations and you have to decide if it's mutually exclusive or not mutually exclusive. So this definition might be important because if you get them mixed up, you're going to get that whole question wrong. All right, so when we talk about mutually exclusive, two events that cannot happen at the same time. So for example, can we have a snow day from school and be at school? No. No, it's one or the other, okay? Can you be a 9th grader and an 11th grader at the same time? No. Nope. You're either a 9th grader or 11th grader. They're mutually exclusive. So another word to think about that is separate. That's kind of the word I use, is that they're separate. All right, this is where I'm going to use a highlighter. I'm going to highlight that word mutually exclusive. The big thing with mutually exclusive is it cannot happen at the same time. They're separate. Okay, so those are kind of our big ideas there when we look at that definition. If I think about this in a Venn diagram, so I have my two circles with that overlap, this is telling us that there is nothing in common. It can't happen at the same time. So we're going to have parts in this circle and parts in this circle, but there's nothing in the middle. It's left empty. There's no overlap. They can't happen together. All right, so I'll leave phone away. Sebastian. All right, probability of A. Now this time we use A or, we use an or, B. So we're only doing one thing. We'll only be rolling a dice one time or drawing one card, but we're going to look for two different things. It could be A or B. To find that probability, we take the probability of A and we add it with the probability of B. All right, we're going to do an example for this right away, and then we're going to talk about not mutually exclusive events. So mutually exclusive, we're going to talk about things that cannot happen at the same time. So we're going to talk about drawing cards. So for example, if I draw, probability of drawing or picking a spade. Remember, spade is a shape. We call those suits. Which one is the spade? Is it red or black? Black. It's kind of like the upside down heart. It's the third one in there. Okay, the first one's clubs, so spade. Okay, or now I want something that can't happen at the same time, that spades cannot be. Spades cannot be red. There is never a card in the deck, in a normal deck, that is both a spade and red at the same time. Okay, it could never happen that there's both. I don't know, I put an equal sign. What are you doing? No, not just 1 second. No. Math. All right, so we're going to find the probability of a spade first. So we talk about spades. How many spades are in the deck? When we look at the shapes, we're going up and down vertical on that chart. So if you need to look back at the chart on the board over there. Spades, how many are there of each suit? There's an ace of spades, 2 of spades, 3 of spades, 4 of spades, 5 of spades, all the way up to king of spades. So altogether there's 13, yep. Out of how many altogether? 52. That's one way to think about it, or we can simplify it. If we simplify it, we can think about it as shapes. How many shapes are spades on the deck? It's one of the suits. Out of how many suits? 4. All right, then we're going to do the probability of a red card. Now, red cards aren't the shapes, or it actually combines shapes. What 2 shapes are red in the deck? Diamonds and hearts. Good. So how many cards are red? 26 out of 52. Or when we simplify that, we could think, how many colors are there in a deck? 2, and red is 1 out of the 2. Good. So half the deck is red. All right, so to find this together, probability of a spade or red. We're going to take the probability of the spade, which was 1/4. You could say 13 out of 52. Use either one. And then we're going to add it with the probability of the second thing, so probability of red. So plus the probability of red is half. So if you need to write that a little bit below to remember where these came from, this was our spade, this is our red. Now when we add fractions, it's not the same as multiplying. When we add fractions, we have to make sure we have common denominators, so we would actually need to do some we'd have to make some equivalent fractions. Okay, I personally, making equivalent fractions and adding fractions to me is just a lot of work. So I like to just use Desmos, so I'm going to do 1/4 plus 1/2. Desmos is going to do that for me. So I would need the same denominator. So instead of saying 1/2 here, I could say 2/4. So it's really 1/4 plus 2/4, which is 3/4. So it's not the same as when we multiply. It's not quite as easy just to look across. So 3/4, which is 0.75. Okay, now when I do times 100, what's really important is if I just write times 100 here, is 0.75 50%? No. So I either need to put in parentheses or I can hit that enter, and then to get the answer there's this A and S button. So I'm going to take that answer times 100. Because there's adding involved, I can't just say times because it'll only multiply the last part. So 75%. That's our answer. How are we feeling? Kind of making sense here? So really we're thinking, is there an overlap? Is there a part where both are happening at the same time? Is there a card that's both a spade and red at the same time? Nope, spades and reds are completely separate, so it's mutually exclusive. So that brings us to our last term today, which is not mutually exclusive. Now this can be a little confusing. It's kind of like fiction and nonfiction. When I think of the word nonfiction, I think of not. And sometimes that gets me confused because it's like nonfiction means it's not real. Like not means not real. But nonfiction means it's not fantasy, it's not fiction, which means nonfiction is actually real. It's what happened in the real world. Okay, kind of the same idea with not mutually exclusive. Mutually exclusive means that they can't happen at the same time. So not mutually exclusive means that they can happen at the same time. So we're kind of pairing them with different words, which is like a little goofy. So two or more characteristics that can happen at the same time. Keon, that's so loud, bro. All right, so again, not mutually exclusive, or they can happen at the same time. So the way I like to think about it with that word not, it means that it is not separate. So those are the words that I use to remember it, because when it's not mutually exclusive, that actually means it can happen together. If it's mutually exclusive, they can't happen together. It's a little goofy. So I'm going to switch colors here. So switch with a person that you're sitting with, or if you grabbed another highlighter, I'm going to use green this time. Use whatever color you want. So not mutually exclusive means that it is not separate. And kind of our key here is it can happen at the same time. So when I look at a Venn diagram of two events, there can be stuff on the left side, there can be stuff on the right side, but we do know that there is stuff in the middle. Now this formula is different. So again, this formula is going to be important to write down along with these definitions today. Highly recommend, because when people get to the test, they look at this problem and they're like, why are there three things? There should only be two things. There's three things. So again, we're doing probability of A or B. To start off with, we're going to start with the probability of A, and we're going to combine that with the probability of B. But if I count all of A and all of B, there's going to be some overlap. There's going to be some overcounting that happens. So in this class, if I count up 9th graders and 14-year-olds, raise your hand if you're a 9th grader. Raise your hand if you're 14. Are there some of us that raised our hand for both? Yeah. Are there some of us that just raised our hand for 9th grader? Yeah, because we're 15, right? So if you raised your hand for both, I counted you twice. Are there two of you? Nope. So we have to take that away. We have to decide, oh, we overcounted, something's wrong, so we have to take away that part of that overlap, the probability of A and B. Because when we add the probabilities together, we're going to be overcounting, so we need to undo the overcounting. We need to take away. All right, so this is example 2. Last example for today. Again, we're going to talk about cards because cards here is really one that we can talk a lot about. I don't know, there's lots of things we can talk about with this, but I'm going to start with that. We're going to say probability of drawing a face card. Or a diamond. So in order to decide if this is mutually exclusive or not mutually exclusive, I need to think, is there a card in the deck where both of these can happen? It's a face card and a diamond at the same time. If you're not sure, remember you can look over. Face cards are the J, Qs, and Ks. J stands for Jack. What does Q stand for? Queen, and K is King. Okay, I don't really know what a Jack is, to be honest. I'll Google it someday. Okay, but those actually have people on them, so that's why they're called face cards, because there's an actual face on them. for jacks, queens, and kings. Are any of those jacks, queens, and kings also a diamond at the same time?
No.
Yeah, which one is the diamond?
All of
They're not all diamonds. The queen of diamonds, right? Okay, queen of diamonds would be one that's both. So that's why it's not mutually exclusive, because there's some that are both. If I pick a card, it can be a face card and a diamond at the same time. All right, so probability of a face card. This one we have to find 3 probabilities because we have 3 parts to our formula. So how many face cards are there in the deck of cards? When we look at J's, Q's, and K's, all together, how many J's, Q's, and K's are there? 12, because there's 4 of each. So 12 out of 52. Now, I'm personally going to not simplify it yet because we still have to do this anyways, so it might need to be simplified differently. I like to just keep it 12 out of 52. Probability of a diamond, that's our second thing. So now we're switching our brains to thinking just diamonds. How many diamonds are there in the deck? Remember, diamonds are a shape. They go up and down. It's vertical. Yep, 13. There's 13 of each suit out of 52. But now I need the probability that A and B, the both. How many cards are a face card and a diamond at the same time? 3. There's the jack of diamonds, queen of diamonds, and king of diamonds. So 3 out of 52. So when we counted it, if we count all face cards and then we count all diamonds, we overcounted. We counted the jack of diamonds twice. It's both here and here. So we have to subtract it out. So our probability of a face card or a diamond okay, we start with our face card, 12 out of 52. Plus our diamond. Our diamond is 13 out of 52. But then we have to subtract the amount that we overcounted by, which was 3. 3 out of 52. Now, because they all have the same denominator, we could actually add and subtract left to right. So those of you that want to do it in your heads, 12 plus 13, 23 minus 3. What? 12 plus 13? 25. 25 minus 3? 22. Okay, if you wanted to, you could do it that way, but then you do have to double check that to simplify it. So if I go on my calculator and I type it in, 12 out of 52 plus 13 out of 52 minus 3 out of 52. Okay, in my calculator, it tells me 11 out of 26. Does that mean we did something wrong? Nope, it's the same answer. The calculator just simplifies it for us right away. So it just depends on how your brain works. Some people, their brain works so fast that they look at this and they're ready to just start adding across and then simplify at the end. Some people are like, that's a lot of work. I'm just going to put it in my calculator. All right, so our probability is 11 out of 26, which is equal to, let's do 3 decimal places. So 4, 2, 3. After the 3 is a 0. So do we keep it at 4, 2, 3 or change it to 4, 2, 4? 4, 2, 3. Good. 0.423. Okay, I'm going to enter. I'm going to use that A and S button to grab that answer that I just had times 100. Do I want 42% or 43%? 42%. All right, here is the dealio. Overall, we still have about 30 minutes. What are you doing?